Welcome to Trajectories for Systems with Complex Eigenvalues. So recall, if we have y prime equaling a times y with a n by n constant, with complex eigenvalue, lambda equals alpha plus beta I, and corresponding eigenvector psi equals u plus I times v. Then we had solutions, or then we get solutions y1 is u times cosine of beta t minus v times sine of beta t, all times e to the alpha t. And our y2 is v times cosine of beta t plus u times sine of beta t, again times e to the alpha t. So what does this mean for trajectories? So in the 2x2 case, we have fundamental solution, or we have general solution. Y is equal to C1 times u cosine of beta t minus v sine of beta t times e to the alpha t plus C2 times v cosine of beta t plus u sine of beta t, all times e to the alpha t. So note that if if alpha is greater than 0, the solutions will head outwards. So the solutions head away from the origin. Since our scaling will get larger and larger and larger. If alpha is less than 0, then the solutions will head towards the origin. And if alpha equals 0, then we wind up just with cosine sine, which are periodic. So if alpha equals 0, then our solutions are periodic and we just kind of cycle around. So let's now focus on the cosine sine component. So let's look just at what happens if C1 equals 0 or if C2 equals 0. So if C2 equals 0, then we're looking at C1 times U cosine of beta t minus V sine of beta t times e to the alpha t. This U cosine beta t minus V sine of beta t is periodic. And it essentially cycles around our origin. And then the e to the alpha t will have us grow, shrink, or stay sort of same distance. So it turns out that the way that we the way that time passes, you can determine which direction will be going around sort of in our circles based off of the u and the v. So this component essentially circles around, or essentially circles around the origin. And the direction of travel is based off of u and v. I need to give myself a little more space, so I'm going to do that quickly. Well, let's go ahead and just take a case where we draw representative u and v. So if we have a u and v, it turns out that the direction of travel can be just found essentially by using your hand and creating that vector. So if you put your thumb along u and your pointer finger along v, then following your thumb to pointer finger tells us the range of motion. So in this case, if we draw our hand, so we have our thumb and then our pointer finger, right? And then put the rest of the fingers away. Right? So we draw our thumb on U and our pointer finger on V. The direction of travel is based off of following the pointer finger. So if our direction of travel would go from U and hook around on V, and it looks like in this case, we would be going counterclockwise. So here my U is in the first quadrant, my V is in the fourth quadrant. If I do that thumb on U, pointer finger on V, we have this counterclockwise direction going. And so we know that essentially we're going to be moving this direction. And then if we had U in the first quadrant and V in our second quadrant, so if we draw our U in the first quadrant and a V in our second quadrant, and we draw that picture again with our hand, we would put our thumb on U and our pointer finger on V. So we have our thumb along U, our pointer finger along V. And if we follow that direction around, following our pointer finger, this time around, we are getting clockwise motion. So in this case, essentially, we go around clockwise. So this is a trick you can use just using your hands and the U and V. So what we get is, again, we get this sort of cycle going on. So we get a cycle. If alpha is greater than 0, so in other words, if the eigenvalue has positive real component, then we spiral outward. As time passes. And if alpha is less than 0, if the eigenvalue has negative real component, then we spiral inward. So just sort of sketching. If we have our U in the first quadrant, V in the third quadrant, again, this is a case where we are doing our spiral counterclockwise. And if we had, say, alpha less than 0, so we know that we're going counterclockwise. And then alpha less than 0 means that we're spiraling inward. And so we're going counterclockwise, and as time passes, we're heading inward. So this is what we're looking for. Let's go ahead and use an example. I believe that this was actually supposed to be a +3, not a -3, but let me just verify that. From the example, this is the example we did in the previous problem, or previous video. All right, so looking at an example from our previous video, we solved the system y prime equals 3, 4 for the first row, -5, -1 for the second row, multiplying y. In the previous video, we found an eigenvalue of lambda equaling 1 + 4i with eigenvector psi was equal to 2 + 4i and then -5. Again, let me just verify that I copied those correctly. So if we are going to do our sort of trajectory, the only thing we need to know is the sign of our alpha and our u and v for our eigenvector. So psi we can rewrite as 2 -5 plus I times 4, 0. So our u is 2 -5. Our v is 4, 0. And then our lambda is 1 + 4i. So we have alpha is 1 and beta is 4. This is actually all the information we need to do our sketch. We do not need to have the general solution solved for. So we can go ahead and sketch 2, -5 and 4, 0. So 2, -5 will go into the third quadrant. This is our U. 4, 0 is on the x-axis pointing to the right. This is our V. If we do our thumb pointer finger, we have our thumb along the U and then our pointer finger along V. So if we trace that path, this is a case where we are going clockwise. Again, we go from the thumb out the pointer finger, we're going clockwise. So we know that we have a clockwise motion. And then alpha is greater than 0. So this means that we spiral outward. So we come from the origin, heading clockwise, spiraling outward. And this is what our trajectories look like. I only did the case where C2 equals 0. It turns out C1 equals 0 or any linear combination. We do get the spiral all in the same direction, or sorry, the motion in the same direction. So you only need to worry about this. Where is U, where is V, and what does this pointer finger rule tell us? I'm drawing these hand signals because I'm not quite sure if my video is coming up backwards or forwards. So you want, again, the motion comes from the thumb through U and then out V, tells us the direction we're going in. So this is how we can go about sketching our trajectories.